2007 Ford Taurus SE with a 3.0 liter engine. No drivability complaints with this one, just a check engine light. Okay, here's the shot of the trouble codes. We got a P0405 EGR circuit low and also a P1000 code. That's OBD2 system checks incomplete. Quick note on this P1000 code, and it's something that we need to be careful of when we're working in the field. What this means is someone cleared the codes on this vehicle before they brought it to us, and that means that there is the possibility of other faults on this system that have not been tested yet. So we need to make this customer aware that the code that we're chasing right now is this EGR code only, and that any other fault codes that would return are separate charges. So again, we're just addressing this P0405 trouble code, and we're going to warn this customer about this P1000 code in memory. Okay, the hardest part about doing these is where I want to take you next and what direction we want to go. And what we could do is just go right to a flow chart, this P0405, get some information about the code. We could also use the scan tool and go through the troubleshooter and see if we can get some help there, and I think that would be a very good beginning point. I don't need to do it. I know this system like the back of my hand, but I think for some of you guys that are new at doing this, it's helpful to look at this from all different angles. And I think the first one that I'm going to show you because of that is the troubleshooter. Let's see what kind of info we can get with this P0405 trouble code using the scan tool. I mean, why not? We don't have to leave the car. We can stay right here. So we'll go down to our troubleshooter, go to our engine, go to our code tips, and we're looking for our P0405, so it'd be in the 400 range. There is a 405 code. It says differential pressure feedback, exhaust gas recirculation sensor circuit low voltage detected. So that's our DPFE sensor. Scroll down. It says the exhaust gas recirculation monitor checks the DPFE sensor signal to the PCM for low voltage. Test fails when the average voltage to the PCM drops to a voltage less than the minimum calibrated value. Possible causes: DPFE circuit short to ground, damaged sensor, vehicle reference short to ground. Diagnostic aids: a DPFE PID reading less than 0.2 with the key on, engine off, or running indicates a hard fault. So some good information there that we're at 0.2 or less of a volt on the DPFE sensor is going to set this fault code. So for you guys that are new at doing this, don't forget about the troubleshooter info that Snap-on has. We don't have to go run to Mitchell or the computer or Google. We can go use the information we have. So we have some direction. We're going to go to the DPFE sensor next. I'm going to hit no. We're going to go right back to our scan data now that we know what we're looking for. And we're going to go emissions and fuel. There's separate data menus here. Each one of them has specific data PIDs. If you can't find it in one particular data list, you pick another one. And we're going to pick emissions and fuel. Most likely this DPFE sensor signal is going to be on there. And for the camera, I'm going to choose a PID list just to make it easier to look at. And we'll go... I'll just go a single PID for now. Nice big giant one for you guys. And there is our DPFE sensor voltage signal. Right now with the key on, we're reading 0.13 of a volt, which is less than that 0.2 number that we just read on the troubleshooter. Valuable information for sure. This is a hard fault right now. So the fault is occurring right now. This should be very easy to troubleshoot. Okay, what we're looking at now is actually the flow chart for the P0405 trouble code. And this would be if you did not have a Snap-on scanner that gave you troubleshooter information. This is where you would have been forced to go next, is to get an idea of what this 405 code is and what it means. And it says EGR, or exhaust gas recirculation sensor A circuit low. It gives us possible causes, which is cool. Talks about the differential pressure feedback sensor for the EGR, just like we read on the scan tool. And what I wanted to do is show you guys how much of a nightmare these can be when you're doing it this way. And if you follow this, it gives you possible causes, which is great. And then it talks about the pinpoint test, which is actually our flow chart for this code. And then it says vehicles equipped with a ESM, that's an EGR system monitor, or all others. Notice we have two different pinpoint tests. This one's HH and this one's HE. And so a little bit of research is important to know which system we're dealing with. And what I did, I can't show you all the steps that I do all the time, but what I did for you guys is I got a picture of what the EGR system module is. In fact, I was a little bit unsure. I had an idea because I've run into these on some newer Fords, and this is actually what Ford calls the EGR system module. What they've done on this design, this is the newest design, and all I did was Google image EGR system monitor for a Ford, and I got this picture. What they've done is they've taken the EGR valve and they've added the EVR solenoid and the DPFE sensor all in one unit. So all we really need to do to know if this has the EGR, what this flowchart is calling the EGR system module, which is again this device, all we need to do is do a visual inspection of our EGR valve and see what design we have, and then we'll know which flowchart to follow. It is not this one. I've already done it. It's the single vacuum hose going to the EGR. It's the older design, even though this is a 2007. It's the older design. It's not this one. So our pinpoint test that we're going to follow is HE. If you were following a manufacturer flowchart, it would be this one. So I wanted to inform you guys on how we did that. Okay, quick shot here of our flowchart. I printed it out. This is the HH one. This would be the one we would follow again if we had this design right here, and we don't. We have the older design, so we're not following that one. This one's 14 pages long, so we're kind of like, whew, we don't have to follow that one, right? Well, we come to the other one that is not the module design, and this one is 34 pages long. So we just thought we dodged a bullet, and we didn't. 34-page flowchart potential for this HE pinpoint test. Now, you wouldn't follow all 34 steps necessarily. We would start at step 1, and sometimes at step 2 you can skip to step 90. Depends on your situation and your problem. I'm not going to follow this flowchart with you guys. What I'm going to do from this point, explain to you how the system works. We're going to test it my way using my methods, and we're going to cut this 34-page flowchart down to a 5-minute test. That's our goal. That's what we want to do. So what I need to do that is talk about this design that we have on this car. Again, Google image, that's where I got this from. And so looking at this system, you can see that we have a vacuum controlled EGR valve right here. That vacuum comes into this location, the valve lifts, and we get exhaust flow into the intake. That EGR valve lift or control or vacuum is controlled by a computer controlled solenoid. It's called an EVR solenoid, EGR vacuum regulator solenoid. So the computer is going to control the pulse width. It's a pulse width modulated solenoid or duty cycle controlled solenoid. Computer's going to control the on time of the solenoid, which controls the amount of vacuum that's going to flow through this to the valve. If we lower the on time, we will lower the vacuum supply to the EGR. If we increase the on time, we will increase vacuum supply to the EGR, and with that, the amount of lift, the amount of valve opening. So from there, the system is monitored for flow, and that's done by our DPFE sensor, which is over here. So this DPFE, that's differential pressure feedback. It's called differential pressure because what it uses is two separate readings of pressure. One on the exhaust side of an orifice, that's our EGR tube. This will be that metal tube that runs up to the EGR valve from the exhaust. It's about a, I don't know, maybe a 1/2 inch diameter, 3/4 inch diameter tube. So a pretty big tube, and it has a orifice or restriction in the middle of it. And what we'll do is we'll take a sample below the orifice and a sample above the orifice of pressure in this tube. this sensor is going to take that pressure signal, convert it to a signal the computer reads as the amount of EGR flow. When the valve is closed, our pressure in the tube is equal on both sides. And so with no difference in pressure, we'll have low voltage from this sensor. And the range that I saw on actually the flow chart I used for the range, it said, I think it was 0.35 to 1.3 volts at idle, depends on the car, depends on the design. We'll see a pretty big range. The number that I use in my book for you guys, generally between a 0.5 volt and 1 volt at idle with the EGR valve closed is a number that I use. That is pretty standard across the board. So no change in pressure between these two, that means the valve is closed. Okay? And that's going to be key on engine off or key on engine run. That pressure is going to be equal, so it really shouldn't be much different. Very, very slight change from engine off to engine run because the difference in pressure is still the same. Now, as soon as the valve starts to open, what happens because of this orifice here, this upper chamber area will be exposed to intake vacuum. So the upper chamber area pressure is going to drop because of that. And so now we start to create a large difference in pressure here compared to the lower one. The more the difference in pressure, or the greater the difference in pressure from here to here, the greater your signal voltage will be going to the computer. And that's how the sensor works. That's how the system operates. Now with this, imagine this, we can kind of get an idea why this is a 34-page flow chart. This system has issues everywhere. We can have I'm just going to mark up this page for a second. We can have an issue as far as an EGR flow code. Now we don't really have a flow code. We have a low voltage code on this sensor. So we're kind of limited with our problem, where we're not going to have to follow all these other procedures, and that's where this 34-page flowchart seems intimidating going into it, but with our particular fault, it really isn't. We can follow the flowchart. We're not going to. We're going to follow it, again, like I said, with my method. But if you have a Ford and you have an EGR flow code, you could have an issue with this hose, right? The supply to the EVR solenoid could be broken or restricted. We could have a problem with this hose. From the EVR to the EGR could be an issue. We could have an issue with the solenoid itself, with the power to the solenoid, or the control to the solenoid, which, by the way, is ground side switched. Section 3, right? Power ground side switching applies right to that. Section 3 in my book. We could have a pressure sensor problem. We could have a reference signal or ground problem, and this would be Section 8, right? Section 8, pressure sensors. We could have a supply issue to the DPFE on this upstream hose or the downstream hose. Actually, I've seen these where guys will switch them. This hose will be connected here, this hose will be connected here, and it goes crazy. When the EGR valve opens, it goes the other way around. It's kind of weird. We could have a EGR valve restriction, or the valve itself, or we could have an intake restriction right here as far as flow codes go. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Really 11 or 12 different problems for an EGR flow code on a Ford. Now some of you might be thinking, well, what about the tube and the orifice? And I have to tell you, I have never seen that orifice get restricted. It's on the exhaust side of the system. We don't build up carbon deposits on that side. Our carbon deposits are going to build up on the intake side where it rapidly cools, where it enters the intake. So a little bit unrelated to this video, but most of our EGR flow codes on Fords are going to be that side right there, that intake side of the EGR, or it's going to be this DPFE sensor. So here's what I'm going to do with you guys for this video. We're going to focus on the DPFE for sure. But what we're going to do is we're going to be the computer, and this is a ground side switched circuit right here to the EVR. We're going to take a test light to ground with key on engine run at idle, and we're going to energize the solenoid. We want to hear the engine get real rough. If it does, that means the valve opened and the passages are clean, and then when we do that, we want to focus on our DPFE signal at the same time over here. We're going to watch that signal. If the engine gets rough and just about stalls, that means we have flow taking place in our tube, and that means we should have a difference in pressure in the top tube compared to the bottom one, and we should see a DPFE signal rise. This is what we're going to do first. All we need to do is T-pin, test light to ground, engine running while we're watching scan data, DPFE voltage, and listening for the RPM to get rough. So that's the test. That's what we're going to do. Okay, so back on the car, looking at our DPFE voltage. Again, the concern with this vehicle right from the get-go with this fault is the DPFE sensor in the wiring. We're not so much worried about flow and that other stuff, but we're going to do the test anyway. And the reason I choose to do it this way is I'm going to create a pressure change, and I want to see the DPFE voltage react to it. Right away, it's not reacting like it should, and I know some of you are thinking put a DPFE sensor in it already, right? And I would agree with you, it's a Ford. You know, all of these DPFE sensors go bad. We're going to check it anyway. I think the stuff that we covered is going to be valuable information for other Fords. And then also, we're going to do wiring checks to this DPFE to make sure that they're correct and we don't have an issue with the reference wire, the ground wire, and we can be 100% confident on this sensor. So when we do this test, again, we want to hear the RPM get real rough. So what we're going to do, we're going to go to this EGR and our EGR solenoid. Let me get you a shot of that. Very nice and easy to get to. It's right here in the front. That is our EGR solenoid right there. And what we can do, two things. We can look at the wiring diagram and figure out which one the feed, which one the control is. I got a real heavy red wire, and then I got a brown with, I can't really see the color of that too well without my flashlight, but I know these Fords well enough that it's the smaller gauge wire that is the control wire. And again, I'm using a test light to ground, so if I accidentally T-pin the feed wire, all I'm going to do is light my test light. I'm not going to hurt anything here. This is something that's important that you want to research before you do testing like this, is to know whether or not it's power ground side switched. I know these Fords, it's ground side switched. We're going to do the test now. So I'm going to take a test light to ground there. I'll get you a shot of the location of the valve too. Okay, our EGR valve is right underneath this, looks like maybe a PCV hose. So it's just a single vacuum type EGR. And then the DPFE sensor is kind of buried in the back here. That's why I have the light underneath the car. It is actually that guy right there. You see the gray connector going to this box. Very difficult to see the rest of that DPFE sensor. So that one's kind of difficult to get to, but we'll be able to rely on scan data to test that. So I'm gonna do the test now. Okay, go ahead and start that car for me. Got a nice little power steering whine here. Seems like all these Fords I've been shooting lately have some kind of annoying noise to it. So I apologize for that. Got my test light connected to ground, and I'm going to touch on the EGR control wire. So you heard the idle get real rough. That's great. And generally what you want is that car to just about stall. Now I just did that test when we first started the car, so we'll let it stabilize. We'll redo the test one more time once the idle comes out a little bit more. Try it again, take a listen. Hear how rough that got? Just about stalled that engine out. All right, shut that off. So what that means so far is that my EGR vacuum regulator is good, the supply to the regulator is good, the supply to the EGR is good, the EGR valve is good, our passages are clear in the intake, and definitely our focus goes to this DPFE. Okay, now that you guys saw what I was doing with the test light, we're going to focus back on the scan tool on the DPFE signal. We should see a signal voltage rise when we do this test. Go ahead and start the vehicle back up. Again, I apologize for the power steering whine here. Hopefully it's not drowning my voice out. 0.13 is what we're reading, and what we want to see is a DPFE signal rise. We're going to go ahead and no change at all on this DPFE sensor. Okay, go ahead and shut the car off, turn the key back on so we don't lose our data. Alright, so the last thing that we would do before we start our wiring checks to the DPFE, and I've already done it, is to do a visual inspection on the hoses that go down to the exhaust. Now in this case, even if the hoses were broken off, we wouldn't have that low of a DPFE voltage signal. It should be half a volt, 0.6, 0.7, in that range if the hose was broken. That's not the case. We have an electrical problem here. Now I'm going to use a test I've shown before, and this has to do with the 5-volt signal and how to test it. Section 7 is where we covered it. Potentiometers, where the computer uses that resistor between the 5-volt reference line and the signal line for quick diagnosis for opens and shorts. I'm just going to reach down and unplug the DPFE sensor while I got you guys focused on there. The result of this test is going to tell me everything I need to know about this circuit. At least if it has this design, it should. If it doesn't, there's other ways we manipulate it. Unplugging the sensor. Sweet. I like that. Sensor's unplugged. So we have 5 volts on our signal wire with the sensor unplugged. So I know a couple things here. I know my reference is good. I know my signal is good. There's no opens and shorts. And truthfully, I don't need to test the ground, because if I had a bad ground, I would have higher than normal voltage on the sensor circuit, not lower than normal. That simple unplug it test right there, we're done. 34-page flowchart. Think about this. 34-page flowchart. T-pin in the control wire of the solenoid, knowing how to energize the EGR solenoid, and then knowing about a sensor circuit design with that 5-volt that we've talked about in other videos and I show in section 7. We're done. 2 tests. This needs a DPFE sensor, 100% certainty, no question about it. Final comment, and I'm not going to show it for this video. I think I show it in other videos how to check this DPFE sensor with a voltmeter. In fact, I know I do. Look for a hyperlink. I'll throw a hyperlink in this video for that video where I'm showing that. It was on a Ford Ranger where I'm showing the actual voltage measurements at the DPFE. Not necessary on this one, but if you didn't have a scan tool to do this, you could certainly do voltmeter checks at the sensor itself and do the same exact thing that we're showing here, which is unplug it. If you're at 0.13 of a volt, you unplug it, that signal wire should jump to 5 volts, and that's confirming your circuit integrity right there. So it is able to be done with a voltmeter too. And not, you know, some of you guys get on me with my fancy equipment. All you need is a $10 test light and a $20 voltmeter and a couple of T-pins, and you can diagnose this car with this problem. Okay, just want to get an after shot on this 2007 Ford Taurus, just so you guys can see what a good one looks like. This is after replacing the DPFE sensor. You see my key on engine off voltage is 1.02. I know I'm using a different tool here. Don't worry about that. Before we did this, we had 0.13, it was fixed. Go ahead and start the car. Alright, you can see that we're still at 1.02 volts with the engine idling. Ignore those spikes on the screen, those are self-updating min-max scales. And so what I'm showing here is the same voltage key on engine off as we have at idle with no EGR flow. So I'm going to redo my test. And again, my test is going to be, I'm going to take this EGR solenoid right here. I'm going to put a T-pin in this control wire of it. Next to the insulation, I'm not damaging the wire. I'm not poking through anything. And what I'm going to do is I'm going to take my test lights, connect it to ground. And I'm going to ground that circuit. You hear it get real rough. I'm going to get you a shot back at our DPFE sensor. Now you saw the light was still lit there a little bit because I'm not fully grounding the circuit. Don't worry about that. Just using a test light because it's a safer tool to do this. Again, section 3 If you're unsure about manually energizing solenoids, you can fry an engine computer if you're not careful. Section 3 in my book, very important information before you start doing this kind of testing. So let's focus back on the scan tool on our DPFE voltage. What we want to see with good EGR flow on a Ford, number one, is we want to hear the RPM get rough and almost stall. Number two, we want to see 4 volts on our DPFE signal wire. So I'm going to ground it, we'll watch it. There was an initial 4 volt spike and then it dropped after that. I'm going to hold it there. It won't stay at 4 because the idle's real rough now and our vacuum's very low. So if you want to see that full 4 volts again, just raise your RPM. Right there, with that RPM raised and that EGR jumped, you saw our 4 volt signal. Good flow on this system. That is a confirmed fix, faulty DPFE sensor.